Math lesson number 39. Solving systems of linear equations by substitution. First, let's solve the system x minus y equals negative 3, x plus 4y equals 7 by substitution. Meaning to say we need to find an ordered pair that satisfies this system of equations. So step number 1, solve for one variable. In this case, solve for x in the first equation. So first equation is x minus y equals negative 3. Solve for x, we have x is equal to y minus 3. So we transfer negative y to the other side. So it will become positive. Next step, substitute this y minus 3 for x in the second equation. So the second equation is x plus 4y equals 7. We will substitute this y minus 3 because x is equal to y minus 3 to x in the second equation. So we have y minus 3 plus 4y is equal to 7. Then we simplify. Y plus 4y is 5y, and then we plug in negative 3 is equal to 7. 5y equals 10. Divide all sides by 5, so y is equal to 2. So we have the first coordinate, y is equal to 2. Step number 3, substitute 2 for y in any of the equations. In this case, substitute it in the first equation to solve for x. So x minus y equals negative 3. X minus 2, because y is equal to 2, is equal to negative 3. Simplifying that, we have x is equal to negative 1. So therefore, we have the ordered pair negative 1, 2. Now check the answer. Substitute negative 1 for x and 2 for y in both equations. So x minus y equals negative 3. That's the first equation. We substitute the coordinates. Negative 1 minus 2 equals negative 3. Negative 3 is equal to negative 3, which is true. Next, the second equation, x plus 4y equals 7. Negative 1, that is x, plus 4 times 2, 2 is y, is equal to 7. Then we simplify this left side, that is negative 1 plus 8. Negative 1 plus 8 is 7, which is equal to the right side, 7, which is true. Now, let's have the last step. State the answer. The solution is negative 1, 2, because this ordered pair satisfies the first equation and the second equation. Let's have number 2. Solve the system 2x minus 5y equals negative 28. 3x plus 15y equals 3 by substitution. So first step, we solve for one variable. Now in this case, we will solve for x in the first equation. So the first equation is 2x minus 5y equals negative 28. So we solve for x. We isolate 2x first. We transfer this negative y to the others, negative 5y to the other side, and we divide all sides by 2. So as a result, we have x is equal to 5y minus 28 over 2. Next step, substitute 5y minus 28 over 2 for x in the second equation. Then solve. So the second equation is 3x plus 15y equals 3. So we will substitute this value to x. 3 times 5y minus 28 over 2. And then plus 15y equals 3. Then we simplify this. 3 times 5y is 15y. 3 times 28 is 84 over 2 plus 15y equals 3. Then we multiply both sides by 2. So this one times 2, we have 15y minus 84. 2 times 15 is 30y. And then 2 times 3 is 6. 15y plus 30y is 45y. Negative 84, we transfer this to the other side. So positive 84 plus 6 is 90. So we divide both sides by 45. As a result, we have y is equal to 2. So that's the first coordinate. Y is equal to 2. Step number 3, substitute 2 for y in any of the equations. In this case, substitute it in the first equation to solve for x. The first equation is 2x minus 5y equals negative 28. Now we substitute this 2 for y. So 2x minus 5 times 2 is equal to negative 28. Turning that into 2x minus 10 equals negative 28. We transfer this negative 10 to the other side. So it will become negative 28 plus 10, which is negative 18. And then we divide both sides by 2. As a result, we have x equals negative 9. So this is the second coordinate. Step number 4, we check the answer. We substitute negative 9 for x and 2 for y in both equations. So the first equation, 2 times negative 9 minus 5 times 2 equals negative 28. Simplifying all that, we have negative 28 equals negative 28, which is true. Next, 3 times negative 9 plus 15 times 2 equals 3. This is the second equation. Simplifying all that, we have 3 equals 3, which is also true. Meaning to say this solution satisfies both equations. So we'll proceed to step 5. State the answer. The solution is negative 9, 2. X equals negative 9, y equals 2. So the ordered pair is negative 9, 2. Let's have number 3. Solve the system y equals 2 times x minus 3. 3x plus 4y equals negative 24 by substitution. First step, solve for one variable. In this case, we solve for y in the first equation. Why y? Because y is already indicated in the first equation. Y is equal to 2 times x minus 3. So we just simplify right side. Y is equal to 2x minus 6. Now we substitute this 2x minus 6 for y in the second equation, then solve. The second equation is 3x plus 4y equals negative 24. We substitute 2x minus 6 to y. 3x plus 4 times 2x minus 6 equals negative 24. We distribute 4 to 2x. 4 times 2x, 8x. 4 times 6, 24. 3x plus 8x is 11x. Negative 24 will be transferred to the other side, so that's negative 24 plus 24, which is 0. Therefore, x is equal to 0. So that's the first coordinate. Step number 3. Since x equals 0, we substitute 0 for x in any of the equations. In this case, we substitute x equals 0 or 0 for x in the first equation. So y is equal to 2 times x minus 3. Y is equal to 2 times 0 minus 3. 0 minus 3 is negative 3. Negative 3 times 2 is negative 6. So y is equal to negative 6, which is the second coordinate. Now we have both coordinates. We check the answer. Substitute 0 for x and negative 6 for y in both equations. So in the first equation, y is equal to 2 times x minus 3. Negative 6 is equal to 2 times 0 minus 3. Simplifying all that, we have negative 6 equals negative 6, which is true. Now for the second equation, 3x plus 4y equals negative 24. 3 times 0 because 0 is x, and then 4 times negative 6 because negative 6 is y. Simplifying all that, we have negative 24 equals negative 24, which is also true. Therefore, we'll proceed to step number 5. State the answer. The solution is 0, negative 6. Because 0, negative 6 satisfies both equations.